6.3 Sums and Differences of Rational Expressions. This begins on page 205. I'm going to start on page 208, question 1, which is a true or false question. Basically, it's saying, does x plus 1 over x minus 3 plus x minus 3 over x plus 1 equal to 2? It's very tempting to start canceling out this x plus 1 at the top and bottom and the x minus 3 at the top and bottom, but you can't do that when you're adding or subtracting. When you're canceling out, you really are dividing, and you can only divide what's been multiplied, not what's been added or subtracted. Let's go over some fraction rules. So if we had 1 over 2 plus 3 over 5, what we had to do before, and it still applies, is we had to find the lowest common denominator. So in this case would be 10, right? Multiply the first fraction by 5 over 5. Multiply the second fraction by 2 over 2. And then now, since there's a common denominator, we can add them up together. So the key here is you have to find a common denominator. And it's even better if you can find the lowest common denominator, because then you don't have to reduce it later. So we'll be looking for your LCD every time we are going to be adding or subtracting fractions, whether or not they have variables in them. So in this case, we need to find the lowest common denominator. And they look funny. So my lowest common denominator here is just going to be multiplying those together. So x minus 3 times x plus 1. And so my first fraction, well, there's really two ways we can do this, but I'll do it similar to the one we did before. The first fraction I'm going to be multiplying by x plus 1 at the bottom, which means I also have to multiply the top by x plus 1. Second fraction, I need to have an x minus 3 at the bottom, which means I have to multiply the top by x minus 3. So now I have x plus 1 times x plus 1 plus x minus 3 times x minus 3. And we can do that because my denominators are the same. And they're asking if that equals to 2. Okay, let's multiply out the numerator. So x plus 1 times x plus 1, that's equal to x squared plus x plus x plus 1. X minus 3 times x minus 3 equals x squared minus 3x minus 3x plus 9. I'm going to try to keep this factored at the bottom. So x squared plus x squared is 2x squared. X plus x is 2x. Minus 3x is x. Minus 3x is negative 2x. 1 plus 9 is 10. Let's factor 2 out of the top. Okay, so if this is equal to 2, well, then that means x squared minus x plus 5 must equal x plus 1 times x minus 3. And that's not the case. I know that 1 times negative 3 is negative 3, not 5. So this is going to be false. I do have a 2 out in front, but the rest would have to equal 1 in order for 2 times that number to equal to 2. Question 2, find the lowest common denominator for each rational expression. F, 5 over 8x, and negative 3 over 12x minus 12. So I want my lowest common denominator. I'm going to be looking at the denominators. So 8x. Now to do this the easiest way, make sure everything is in factored form. 8x is already in factored form. 12x minus 12, we can factor 12 out of there. So it'll be x minus 1. So for my numbers, I have an 8 and a 12. Lowest common denominator between 8 and 12 would be 24. So 8 times 3 is 24. 12 times 2 is 24. I need to have an x, and I need to have an x minus 1. So this is my lowest common denominator, 12x times x minus 1. 2L, again, lowest common denominator. We're looking at the denominators, so 4x minus 8. That one we can factor a 4 out of. X squared plus 2x minus 8. Well, let's see if we can factor it this way. Two numbers that multiply to negative 8 and add to 2, positive 4 and negative 2. So our lowest common denominator is going to equal, well, we need a 4. We need an x minus 2, and we have that here as well. And we need an x plus 4. Question 3. Perform the indicated operation. Simplify when possible. Assume the denominators are not 0. H. 8x over 6x minus 5 plus 10 minus 4x over 5 minus 6x. Well, if I'm looking at those denominators, because I'm adding, so I need a lowest common denominator, I'm noticing that we have 6x minus 5 and 5 minus 6x. I like having my variables first, so I'm going to factor out a negative 1 from this side, and then that makes it negative 5 plus 6x, and I can rewrite that as 6x minus 5. I'm noticing that those are the same, so my lowest common denominator is actually 6x minus 5, and if I look at it, both fractions will have it. I'm going to write this negative sign out in front. So I already have a common denominator, 6x minus 5, so I can add or subtract them. So it's 8x plus minus, that makes a negative, 10 minus 4x. Negative times 10 is a negative 10. Negative times a negative 4x is a positive 4x. 8x plus 4x is 12x. We aren't finished yet. I can factor the top. So I can divide by 2. So I factor out a 2. 6x minus 5. My denominator is 6x minus 5. Those are the same. Since I'm multiplying 6x minus 5 times 2 and dividing it by 6x minus 5, then I can reduce this. 6x minus 5 divided by 6x minus 5 equals 1. 2 times 1 is 2. 3p, 2x squared plus 1 over 2x squared minus 5x minus 12 minus 4 minus x over 2x squared minus 5x minus 12. Well, my lowest common denominator is 2x squared minus 5x minus 12. I wonder if we could factor that. Might need to later. I can factor this. Okay, so my denominator is 2x plus 3 times x minus 4. My numerator is going to be 2x squared plus 1 minus brackets 4 minus x. Okay, let's distribute the brackets in the numerator. So I have 2x squared plus x minus 3. Let's see if we can factor 2x squared plus x minus 3. We can factor this. Okay, so let's put it into our equation now. Is there anything we can reduce? 2x plus 3 is in the numerator and the denominator. X minus 1 is only the numerator, not the denominator. Okay, So our answer is going to be x minus 1 over x minus 4. Question 4. Perform the indicated operation, simplify when possible, assume the denominators are not 0. B, 5 over 3x squared y cubed minus 1 over 6x y to the 4th. First job of subtracting, lowest common denominator. Nothing can be factored. Okay, so numbers 3 and 6, the lowest common denominator, there will be a 6. X squared and an x. So x squared, y cubed, y to the 4th, y to the 4th. I've asked to simplify it. Okay, so our first term, we need to multiply everything by a 2. 2 over 2. We don't need another x, but we do need another y. So we're going to multiply the first term by 2y over 2y. Our second term, we're going to multiply it by, we already have a 6. We need one more x. And we have 4 y's already. So 2y times 5 is 10y. 2y, so 2 times 3 is 6. We have an x squared. Y times y cubed is y to the 4th. Minus 1 times x is x. 6 times 1 is 6. X times x is x squared. And we still have our y to the 4th. The denominators are the same. So 6x squared y to the 4th. 10y minus x is the numerator. That's all we can do. For f, 4z over z minus 1 minus 4. Lowest common denominator. Well, remember this is 4 over 1. So our lowest common denominator is going to be z minus 1. Okay, so in our first term, we already have z minus 1. Our second term, we need to have z minus 1 in the denominator. So we're going to multiply it by z minus 1 over z minus 1. Okay, so we have 4 times z minus 1. 1 times z minus 1 is z minus 1. So our denominator is now z minus 1, because that's common. 4z minus 4 times z is 4z. Negative 4 times negative 1 is plus 4. 4z minus 4z is 0. So it's going to be 4 over z minus 1. X over 2x squared plus x minus 1 plus 3 over 3x squared plus 2x minus 1. Well, the denominators are very different. Let's first factor the denominators. So 2x squared plus x minus 1. Let's do our box method. So we can factor this. Let's factor the other denominator. Box method again. And we can factor it. Okay, let's copy our numerators. Okay, so our lowest common denominator is going to be a 2x plus 1, x plus 1, and 3x minus 1. And we already have x plus 1. Okay, so this is our lowest common denominator. We're going to need to multiply the first fraction by 3x minus 1 because that's not there already. So 3x minus 1 over 3x minus 1. And our second fraction needs to have a 2x plus 1. So we have 3x minus 1 times x plus 3 times 2x plus 1 all over 3x minus 1 times 2x minus 1 times x plus 1. Let's multiply out our numerator. So 3x squared minus x plus 6x plus 3. I am leaving the denominator in factored form. I'm hoping that perhaps I can factor the numerator and things will reduce or cancel out. It's minus 5x plus 3. And I could try the box method for 3x squared minus 5x plus 3, but I have found out that's not easily factored. You can use the quadratic, but again, you're not going to get something that will easily be factored, so chances are it's not going to be like a nice number like a third or something. And so I would leave the answer in this form.